And tomorrow we will be discussing translations. Thursday and Friday, we will be discussing reflections. Next week, October 19th through 23rd, we will begin our week on Monday and Tuesday with rotations, followed by a quiz on Wednesday, and we will wrap up our week Thursday with congruent figures and Friday with dilations.
Ladies and gentlemen, good morning. For your notes, pause your video. Make sure that you copy what we see. (2.2) Reflections, the essential question, as well as the reflection rule. Super important that we capture the rule or rules for reflection. This should be in your notebook, so make sure you pause the video and copy it as you see it. So for reflections, the one thing that you should make sure that you're looking for when we are doing reflections, you're looking for mirror images. And so we've already said that we consider a reflection a flip. And what you're looking at on your screen is the image being flipped from one side of the coordinate plane to the other. This would be a vertical reflection because we're reflecting this image A, B, and C across the y-axis. And so remember, the y-axis is the axis that moves up and down. Y-axis. As we investigate a little bit further, if you look at the line of reflection, we have 1, 2. It's 2 units away from the line of reflection. So when we reflect it, it remains 1, 2 units away. B to B prime, again, both of those are 2 units. So from the line of reflection, 1, 2. B prime is 1, 2. A prime, 1, 2, 3, 4, 5. From A, then when we look at A prime, 1, 2, 3, 4, 5. So all of our vertices are the same distance away from the line of reflection. Those are the things that we're looking for when we're determining if something is a reflection or not. We look for mirror images. So example 1 of reflections, we're going to look at the rule. So I'm going to start with red. And if we're going to reflect across the x-axis, x-axis is here. So if we're reflecting across the x-axis, remember, if we label this triangle A, B, C, we're going to change it to A prime, B prime, and C prime. First, we want to identify the coordinates. So A is at -1, -2, -3, 1. B is at -1, up 1, 2, 3, -1, comma 3. And C is at -5, up 1, 2, 3, 4. C is at -5, comma 4. So when we reflect across, A is 1 unit away from the line of reflection. So A prime should be 1 unit away from the line of reflection. A prime is at -3, -1. B prime is 1, 2, 3 units up from the line of reflection. So it should go down 1, 2, 3 units from the line of reflection. -1, 3, -1, comma, -3. C, and again, that would be B prime. C is up 1, 2, 3, 4 units from the line of reflection. So C prime will be 1, 2, 3, 4, 5 units from the line of reflection. Excuse me. Yes. Correction. C is up 4 units. 1, 2, 3, 4 units. So we come down 4. 1, 2, 3, 4. C prime is at the coordinate -5, comma, -4. We connect the points. So that is an example of a horizontal reflection. We're reflecting across the x-axis. So when we reflect across the vertical axis, or the y, the rule stays the same. So again, if we're moving A, we start at the line of reflection and count. 1, 2, 3. Starting at the line of reflection, we're going to go right 3. 1, 1, 2, 3. This would be A prime. So we would go right 1, 2, 3, up 1. So this coordinate will be +3, +1. B prime, line of reflection, 1 unit, 1 unit. So 1 unit to the right, +1, up 3, +3. This is B prime. For C prime, starting at the line of reflection, we count 1, 2, 3, 4, 5. From line of reflection, 1, 2, 3, 4, 5. Coordinate is +5, +4. 5, comma, 4. And again, connect our points. A prime, this, B prime, C prime. And so this image is a reflection across the y-axis. And here we have a reflection across the x-axis. If you have graph paper or can get graph paper in order to draw these, I suggest you do so. However, re-watch the video so that you understand how to do it, because it's important for you to be able to demonstrate it on your homework. So if we apply the rules, again, we go back, identify the coordinates. If we're looking at A, B, and C, A, B, C. A is at 1, 2, -3, up 1, -3, 1. B is at -1, 3. C is at -5, 4. For across the X, across the X. The rule says I look at the original coordinates, x, y, and the y value becomes the opposite of the original coordinate. This does not say -y. Again, this says opposite y. Same x value, opposite y value. Same x value, opposite y value. So if I'm reflecting across the x-axis, and again, that's a reflection across this line, A prime, B prime, and C prime all should have the same x values. So I simply rewrite -3, -1, -5. The opposite y's say that these values now become the opposite. So +1 becomes -1. +3 becomes -3. +4 becomes -4. If we remember yesterday, quadrant 1, the coordinates are positive, positive, negative, positive. Quadrant 3 is negative, negative. Quadrant 4 is positive, negative. If we're reflecting from quadrant 2 across this line, we're going from 2 to quadrant 3. If we're going from quadrant 2 to quadrant 3, both coordinate points should be negative. Here, both coordinates are negative. Both coordinates are negative. So we know that we should have done something right. If we look back at the previous example, -3, -1 for A, -1, -3, -5, -4, we know that it was done properly. So for a reflection across the y-axis, I'm going to rewrite these coordinate points first. Give me 1 second. I'm running out of space. So A, B, and C are -3, 1, -1, 3, -5, 4. So we're going to reflect these coordinate points across the y-axis. A reflection across the y-axis. So again, I take A prime, B prime, C prime. The rule here says opposite x, same y. So I rewrite my coordinates A prime, B prime, C prime. My y value stays the same. 1, 3, 4. And now I rewrite my x values as the opposite. Again, the opposite x, same y. This does not say negative. The rule says the opposite x, same y. If 3 is negative, the opposite of -3, +3. -1, +1. -5, +5. If I'm reflecting across from quadrant 2 to quadrant 1, quadrant 2 to quadrant 1 goes from negative positive to positive positive. Both of my coordinates are positive. And again, if we look back at the previous 1, 3, 3, 1, 5, 4, coordinate points matched up. So applying the rules or moving the coordinate points both work. Whichever of the two is the easiest for you to follow along, that's the method that you need to use. Sometimes, however, you have to be able to apply the rule, or you have to make a decision either on the front end or just do what you know best. So in this example, we have a polygon A, B, and C, and we have coordinate points. I think the rule is the easiest way, but I'll plot the points first and allow you to see it both ways. So for coordinate A, I go to 1, 0. Coordinate B, +7, up 3. And for C, I'm at 8, -9. Now this example, if you notice, we have points that are on both sides of the x-axis. And we're going to reflect across the x. Let me highlight it. So we're reflecting across the x-axis. So for horizontal reflection, key to remember, when I'm reflecting, the points above the axis are going to move to below. The points below are going to end up reflecting above. If we have a coordinate on the axis, it will not change. And let me show you how that works out. So by applying the rule, we have A, B, C with coordinate points. So we have 1, 0, 7, 3, and 8, negative 9. When we reflect it across the x-axis, a reflection across the x-axis says same x value, opposite y. So A prime, B prime, C prime. I rewrite my x values. 1, 7, 8. My y values become the opposite. The opposite of 0 is 0. The opposite of 3 is negative 3. The opposite of negative 9 is 8. Excuse me, negative 9 is positive 9. When I plot these points, 1, 0, A prime stays the same. B prime is at positive 7, negative 3. 1, 2, 3. C prime is at positive 8, positive 9. 8, 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry, that is C prime. This is C. So again, I'm going to plot the coordinates or connect it. What you should have noticed is what I said before. B moves to below. C moved above. And A remained in its position. If we look at the distance from the line of reflection for B, 1, 2, 3. 1, 2, 3 for B prime. C from the line of reflection, 1, 2, 3, 4, 5, 6, 7, 8, 9. From the line of reflection, 1, 2, 3, 4, 5, 6, 7, 8, 9. And A, there was no movement because it was on the line of reflection. It stays in place. So remember, the line of reflection, the values will remain the same distance from the line.
In example 4, it says graph polygon ABC with the coordinates for A is 0, 3, which we'll graph. We'll start at 0, go up to 3. 0, 3, negative 7, which is left 7, up 3. And the final coordinate is at 4, negative 6. 4, down 6. So I'm going to change the color and highlight the line of reflection. It says we're reflecting the pre-image across the y-axis. So that means images that are on this side of the graph are going to move here, and images that are on this side are going to move over here. Again, it's a mirror image from one side of the graph to the other. If the graph is on the axis, if the graph is on the X or the Y, those coordinate points will remain in place, and you'll see that shortly. So again, we're looking at these coordinates. A is 0, 3. B is -7, 3. C, no, I'll put it along the side. So A, B, C, A prime, B prime, C prime. And again, I'm going to start by applying the rule and then plot the coordinate points. So the rule that we're using here is across the y-axis, 0, 7, 0, 3, 0, 3, -7, 3, 4, -6. And again, when I look at the rule, it says the opposite of my X value, same Y. So if the same Y is going to be used, I'm simply going to look at my Y coordinates here and move them to here. So 3, 3, -6. And I'll look at these values and change them to the opposite. So 0, the opposite of 0 is 0. The opposite of -7 is +7. And the opposite of +4 is -4. So again, my A value is the same, A prime. When I reflect B, which is -7, 3, it becomes +7, 3. And when I reflect my C value, it becomes -4, -6. And that becomes C prime. And I connect the values, which you should see, again, as best as I could, a reflection across the y-axis. When we apply the rule, it gives us the coordinate points. If we had moved values or moved points from -7 to the line of reflection was 7 units. From there, we would have tried to move the point 7 spaces. We still would have ended up same location. A would not have moved. Here, we're 4 units away. Here, we're 4 units away. So the values are exactly where they should be.
Things to remember: get started 10:15. Homework 2.2 is due tomorrow. And again, we will resume